Hi everybody. So today we're going to do a math demo for levels easy to medium. The levels can actually vary because you might be in a different age group or grade level, so don't worry about that. Let's just enjoy the different questions. Okay, so let's get started. This is number 1. So we've got a small rectangle here, which I'm going to show you in a bit. And we've got this big square here. So we cut the rectangle from the square. This is the rectangle. And we have to find out what happens to the area and the perimeter. Now the area is everything that's inside here. The area is always like two-dimensional. It's this expanse. So here, because the square always has equal sides, we've got 5 into 5, which is an area of 25. So you can also count these little squares individually and you'll see that there are 25. So when you remove these two, which you can also get from 2 multiplied by 1, so this area is 2 into 1 or just 2 centimeters squared. You subtract it from 25, you get 23. So the area actually decreases. You don't even need to count it. You can just see it and you can tell that it decreases. You can see that in options B and C. So A and D are obviously not the right choices. Now we need to think about the perimeter to find the right answer. So the perimeter is nothing but the borders. So here in the beginning, it has 5, 5, 5, 5, which is 20. The perimeter is 20 centimeter. And then it changes because you cut out this part. Let's see what happens. Now remember that the area is always measured in centimeters square, but the perimeter is measured just in centimeters because you don't really have another dimension to it. So let's see. Here you got 3, 1, 2, 3, these 3. Then here you've got 5, that makes 8. So 3 plus 5 is 8. Another 5, that's 13. And here we have just 4 because this part is cut off. So that'll be 13 plus 4, that's 17. Add 2, that's 19. And 1, that's 20. So this new area with this white shape that is created is 20. The perimeter is 20. And initially it was 20, so the perimeter doesn't really change. It might be quite counterintuitive, but as you can clearly see, sometimes logic defies, and so we've got this perimeter to be 20. It doesn't really change. You can also see it from here. So this 2 centimeter line, it just moved inward, and the same happened with this line. It was here and it just moved kind of inward when the shape changed. So that's why the perimeter didn't really change. And that's your answer. The correct answer is C. Let's go to the second one. So we've got numbers 50 to 100, including the number 50. So we've got these numbers, which make a total of 50, and this extra number here. So total, we have 51 numbers. And out of them, we need to find out which are not divisible by 7 or 11. You could do this by hand, but it's going to take a long time, so we're going to do it with some simple steps. This is more or less the layout. So we've got total numbers from 50 to 100. That's 51 numbers. How many of them are multiples of 7? How many are multiples of 11? How many are the common multiples? That means both for 7 and 11. How many are divisible in total? So all of these together. And then subtracting them from the original numbers, you'll get how many are not divisible. So to do this calculation, we've already got some answers here. 50 to 100, there are 51 numbers, as we've seen before. Out of them, we made a list of the multiples of 7. You could also do this by division method and then take only half of them because we only need the ones from 50 to 100, not the ones from 0 to 50. And then the other ones, the multiples of 11, again, you can do this by division and then subtract the ones that are before 50. Common multiples are of both 7 and 11. In this case, multiples of 77, 7 into 11. The second one is not really a good option because it exceeds 100. So we're going to eliminate that completely. Then we've got the numbers that are divisible by either 7 or 11. So all of these, and subtracting the ones that are coming twice, that are common multiples. As you can see, 77 is coming twice. So I've made a list of these here, a list of these here. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, not counting this, 10, 11. So there's 11 numbers and total was 51. So we subtract from 51, 11. We get a total of 40. That's our answer. So the answer is 40. You can see all the numbers that I'm eliminating. These are multiples of 7 and 11. And the common one that is here. So you can count them, and that's a total of 11. Yes. And now we can see all of these steps at a glance, and the correct answer, 40. Next question. A rectangular block has a height of 9 centimeter and volume 144 centimeter cube. If the base is square, what's the length of the square base? You can see that the base is square here. We need to find its length. Here's the height. So there's a small formula that's pretty simple. That's what we're going to use here. We've got length into breadth into height, because this particular figure is three-dimensional. We've got length into breadth into height, which is 144. So the length and breadth are equal because we've got this here, the base, which is a square. So L and B are equal. So L and L is what we can say about it, which is basically L square. So this is L square, and into 9, which is the height. So I just took it here. That gives 144. So we need to bring this 9 to the other side, and it'll become division instead of multiplication. So your L square is 144 by 9, which is 16. So if L square, that is this area, is 16, one of its sides will be the root of 16, the square root of 16, which is 4. So our answer is L is equal to 4. Let's go to the next question. Anna distributes 20 chocolates to her friends in 10 minutes. She wants to distribute a total of 600 chocolates. How much time will she need? As you can see, she's got all of these chocolates. So now, for distributing these, she's taking 10 minutes, but she's got a lot more chocolates. So how many chocolates per round? That's 20. How many total? That's 600. So how many rounds is she going to need? She's going to have to do 20, then again 20, that makes 40, then again 20, that makes 60, and she has to do that many times. So to get to 600, how many rounds? That's 600 by 20, that's 30. So she has to do this process 30 times to finish all of her chocolates. And each time she does it, she takes 10 minutes. That's the time per round. So the total time will be those 30 rounds into 10. That's 300 minutes. But we don't have the answer in minutes, but we need it in hours. So 1 hour is 60 minutes. We're going to divide this 300 by 60. That's 5 hours. And that's your answer. And that's all of your chocolates together. So you can see that she has the 20 chocolates done 30 times. That's 600 chocolates in 5 hours. Next question. So you use 20% of a stick of butter each time. So each time you're cutting off a little part, and the remaining is 80%. After how many uses will you have approximately 25% left? So you just want to have 1/4 of the butter left. The rest of it should be gone. In how many turns will that happen? Let's see. So each time you have 80%, which means 80 by 100, which is actually 0.8. You can also do it in fractions. It's 4 by 5. Or log method, which is a little more complicated. Let's just do a small calculation instead. So every time we're going to make it zero point 0.8. So starting with 100% of your butter. So when we do zero point 0.8, we are left with 80%, then 64, 51, 40, 32, and it keeps reducing till it gets to 0. But after more or less 7 turns, you have less than 25 left. So your closest answer is 7 turns. The rest of them don't really fit because at 5 turns, she still has around 32.7, which is almost 33%. So that's your answer. Delicious butter. Let's go to the next question. So a cube has a volume of 729 cubic units. What's the area of one face of the cube? Is it 9, 18, 27, or 81? Now, 721 is a really cool number. Since we have cubic units and every volume is expressed in cubic units, we need to see whether this number is a perfect square. So let's see. 729 is actually 9 into 9 into 9, or 3 times 3 into 3 times 3 and 3 times 3. So each side is actually 9. You can get this by the prime factorization of the number. And a small trick is to find out whether the number is divisible by 3, which is when all the digits add up, and in this case also by 9 because all the digits add up to a multiple of 9. 7 plus 2 is 9, 9 plus 9 is 18, and 18 is divisible by 9, so 729 should be divisible by 9. This is a cool trick, but don't worry, you don't have to do that every single time. If you don't remember that trick, it's completely fine. So 729 is this, it's the cube. So each of these sides is 9, length, breadth, height, because in a cube they're all equal. So we need to find the area of one face. We already know the side is 9, so 9 into 9, it's 81 square units. Area is 81, that's your answer. Let's go to the next question. Now you have a cube of side 20 units. Each side is 20, okay? You can see them. Now, we need to find 8 smaller cubes. So we're cutting them 1, 2, 3, 4 in the front and 1, 2, 3, 4 in the back. The total is 8 smaller cubes. Each of them, the length, the breadth, the height is half of the previous one. So if the previous one is 20, each of these little sides is a 10. Now, by what percentage the surface area has increased after you cut the cubes? Let's see. Oh, here's the answer already, but let's see how we arrive at the answer. So the cube is 20 units each side. Then we need to calculate the surface area. So there are 6 surfaces for every cube: up, down, left, right, and front, back. You can see that with a real cube you might have at home or wherever you are right now. So 6 sides into the area of one side, which is 20 into 20, which is 2400. So 6 times of 20 square is 2400. That's the original surface area of that big cube. Now, the little cubes, each of them are 10 units in each side. So we've got the surface area. Again, we'll do 6 because a cube always has 6 sides: up, down, front, back, left, right. So that gives us 6 into 10 square, which is 600. And the total surface area, we actually have 8 cubes, so we have 8 different surface areas. So 8 of those areas, those little 600 areas, that'll be 4,800. So the increase in your surface area is this new area that's 4,800 minus the original area that was 2,400. That's 2,400. So the area actually doubled because from 2,400 you went to 4,800. So that means the increase was 100% because it doubled. You can even calculate it here. And that's your final answer. So the next one, a person draws two parallel lines each day. On day 1, the line is 1 unit long, and then every following day, the length is increasing. So first it's 1 unit, then 2, then 3, then 4. But every single day, there are two of those lines because he or she is drawing parallel lines. So we've got the first day, we've got 2 units, 1, 2. The second day, 2, 2, that's 4. The third day, 3, 3, that's 6. The fourth day will be 4, 4, that's 8, and so on. So the total units are 6642, and the pen is going to run out. There will be no more ink then. So, how many full days can a person draw before the pen runs out? Let's see. We're going to try to do it by formula because this seems like a big number, so we can't really calculate it in the given amount of time unless we use a formula to make things easier. So let's see. The total capacity of the pen is 6642, and we have this magic formula. So 2 plus 4 plus 6 plus 8. It's like all the numbers being added up, and all of them are even. Whenever this happens, we have a very simple formula. It's a really simple trick. You're just going to take the number and the next number. So don't get intimidated because you see n into n plus 1. It just means one number and its next number. So every time you're adding these even numbers, that's the formula for the sum. So 6642 is the sum. So two numbers multiplied when they are consecutive, like they're one next to the other, they should give you 6642. For example, we can try 81 into 82, which is the 81 and its next number, or 82 into 83, or 83 into 84, and 84 into 85. Which one gives 6642? Let's see. The correct answer is 81 because 81 into 82 is going to give you 6642, so the answer is 81. Let's take a look at the next question. So we have some balls that are being stacked in triangular patterns. Row 1 has just one ball. Then you've got 3. Then you've got 6. It just looks like a triangle, doesn't it? And then you've got a lot of them, 10. You see each time they're increasing. So from 1, you added 2 more, you got 3. Then you added 3 more, you got 6. Then you added 4 more and you got 10. And then probably the next line you'd add 5 more to get 15 and so on. So the series looks like 1, 3, 6, 10, 15 and so on until all the balls together give you 1540. That's the total number of balls. So how many lines do you have? 1, 2, 3, 4, 5, 6. How many lines exactly? That's hard to know, right? So we're going to have to use a formula. Again, this is also very simple, okay? So formula for this type of a triangle, remember this is only applicable when the numbers go from 1, 3, 6, 10, okay? That's the series you have to remember. In this case, you'll take n, the next number, which is n plus 1, and the next number, n plus 2, and divide it all by 6. How easy is that? So, for example, 18 will be 18, 19, 20 by 6, or 19 will be 19, 20, 21 by 6. 20 will be 20, 21, 22 by 6, and 21 will be 21, 22, 23 by 6. So multiply all those three numbers and divide them by 6. And you should get 1540. So we'll have to just test them out. You can use your calculator if it's allowed. And you'll see that n is actually equal to 20 because that's the only way the numbers will fit into the formula to give 1540. 20 into 21 into 22 by 6. You can cancel out the 6 and try to do the division, or you can use whatever method works for you. You'll get 1540. So the number of rows is actually 20. So when you stack them and you make 20 rows, you'll get 1540 balls. How interesting is that? And that's our correct answer. Those are all the questions we have today. Thank you so much. Please enroll in our courses for teachers, teacher leaders, and of course, students. We have courses in English, Spanish, and all the other school subjects, including science, math, humanities, and much, much more. Bye bye. Have a good day.